If we make the pH of the yeast ball between 7 and 9, then the yeast will react faster with the hydrogen peroxide because proteins that catalyze reactions typically work best in neutral environments. If we make the pH more acidic, then it will rise slower because proteins that catalyze reactions perform slower in more acidic environments. If we make the pH more basic, then it will react slower because proteins that catalyze reactions perform worse in more basic environments.
If we increase the temperature of the yeast balls to 39 degrees Celsius, but not more, then the yeast ball will react faster with the hydrogen peroxide. With the hydrogen peroxide because proteins that catalyze reactions typically work best in hot environments. If we increase the temperature too much, then the protein catalyzing the reaction will deform and no longer react with the hydrogen peroxide. If the temperature is too cold, then the protein will work much slower because there's less movement of molecules, and it will react slower with the hydrogen peroxide.
If we increase the concentration of hydrogen peroxide, which is H2O2, then the yeast ball will react faster with the hydrogen peroxide because proteins that catalyze reactions typically work best in high concentration of reactants. If we increase H2O2, hydrogen peroxide, too much, then the yeast ball won't react faster because it has an optimal concentration of reactants and the maximum capacity of how fast the reaction can go with a limited amount of catalyst proteins. If we decrease H2O2 too much, then the yeast ball will react slower because there are less reactants for it to collide and react with.
This is what the reaction of hydrogen peroxide being catalyzed looks like.
No.
Catalysts, the proteins that help start reactions, are like puzzle pieces with the reactants. There needs to be a certain fit between the reactant and the catalyst. If the puzzle pieces don't match or don't have the right alignment, then the puzzle won't come out with the right picture. This is why, if we have more puzzle pieces, or more puzzle pieces being tried at one time, we are more likely to solve the puzzle faster.
Keep your little molecules keep them all personal. This is actually a different temperature, and you're taking it from light energy, and you're making it chemical energy, so it does work well. So this is Tuesday, it's pretty good.
This is why we believe an increased concentration of reactants will increase the reaction rate, since there is a higher likelihood that the reactant will interact with the protein.
Very informative.
This is also why we believe that making the reactants move faster with an increased temperature, but not too hot, will increase the reaction rate.